Hi there. This is a short video, so we'll cover very briefly here a very simple concept, but it is an important concept to consider when designing shafts that will have stress concentration in them. So we covered designing shafts and consider that the main stress developing there is the shear stress, and maximum shear stress will be equal to Tc over J. T is the torque, C is the radius of the shaft, and J is the polar moment of inertia. Now, usually shafts have sudden changes in cross sections, so they have bigger diameter, and then they switch into a smaller diameter to transmit the power to different parts of the system. So in that sudden transition of cross-section dimension, there will be we'll have developed here stress concentrations. Similar to stress concentrations that we covered when we considered axially loaded members and normal stresses developing due to holes or notches. So here also this formula tau max is equal to Tc over J is not valid here. We need to adjust the value by a factor called K. And K here is the stress concentration factor that we can get from charts similar again to axially loaded members. You can see the chart here, the horizontal axis is R over D. So R is the radius of this fillet. It's done by usually welding the two parts, or so two kind of different diameter shafts. So R is that, and then D lowercase is the diameter of the smaller shafts, and D uppercase is the diameter of the bigger shafts. And there are different curves, D uppercase over D lowercase. So you need to calculate R over D, figure out what curve to use, and that going up from the horizontal axis, hitting the curve that's representing your case, going to the left to get K. One thing to pay attention to is that C is equal to D lowercase over 2. So this means we are analyzing the stresses at the smaller shaft, and we are considering now for that critical section there, we are magnifying or increasing the stresses developing by a factor of K. So we're not considering the stresses developing in the section that has D uppercase over 2. It's the D lowercase over 2. So it was a very short video, a very simple concept, but again, it's very, very important topic because we have these transitions in transmission systems, shafts transitioning from bigger diameter to a smaller diameter, and we have to account for the stress concentration at such points. All right, take care.